So I'll let you guys read this for a second. Very good? All right. You guys ready to do this? So the basic idea is they're looking for does the amount somebody fidgets, which, you know, that could be, for example, while you're sitting. No, you're good. You're good. There's all sorts of things that are fidgets. And in fact, even for your generation, you know one of your major fidgets. I don't even think you guys are aware of when you're checking your phone half the time, right? Because have you ever looked at your phone and then you're like, wait, what? You go back and look at it again. I was like, I saw that before, but I didn't really see it. Do you guys know what I'm talking about? Yeah. Okay. So what we're looking at is if people are overfed, does that make them fidget more so that they don't necessarily gain weight? And how much does the fidgeting actually influence how much weight they might gain? Everybody good? Now, I got great news. You don't actually have to understand this context to be able to do this anyway. Okay? All right. What do you think we should do first here? What do we always do first here? State the procedure. So, since this is an interval, we're going to do a T interval for beta, where beta is equal to the true slope relating NEA change and fat gain. And we'll check our conditions. Now, you guys notice, how many graphs did I give you? 3 different graphs. This one is the residual plot. This one is the histogram of the residuals. All right, what's my first condition? Yeah, if I look at that plot of the residuals, are you guys with me? There's no pattern in my residual plot. Perfect. Okay, independent?
Is less than or equal to 10% of all young adults, healthy young adults.
Normal. Which graph do I care about here? The graph of the residuals. So the histogram. One variable, it's only the residuals. So we could describe that as, say, normal or not normal or whatever. When you guys look at that histogram, does it look close to normal? Yeah. So we might say something like the histogram of the residuals is approximately normal. Do we see any fanning either in the scatter plot or in the residual plot? So that equal variances, the variability of the graph is the same all the way across the x-axis. Okay, so sweet. We got one more condition.
Miss Meister, really quickly, what would fanning, like what's an example of fanning? Like what would fanning look like? Okay. Thank you.
Okay, what's the R stand for? Random. How are we doing there? Given that the sample is random. Boom, we've checked the conditions. The conditions are the annoying part of this. The calculations aren't nearly as bad. Okay? All right, next. To construct the interval. I'm just copying this from the previous page. I've got some really good news. Two of those three values are already given to you. We just need to know where to look. Okay, do you guys remember using these regression outputs? If I asked you, according to this regression output, what is the slope? What would you say? 3.5051 is in fact the y-intercept. Oof. No. Okay, you guys. The equation looks like this. The general form of the equation is y equals a plus bx, yes? How would you, using math vocabulary, describe b? The coefficient of x. And what is x in this case? The NEA change. Is everybody with, are you guys with me? So if I asked you what is the coefficient of the NEA change, what would you say? Negative 0.0034. That row is the row of all the slopes. Now, you guys, using math vocabulary, what is A? The y-intercept, okay. Does it have an x with it? What do we call a number that doesn't have an x with it? A constant, because it's always the same number, so it remains constant. So that 10 point, the constant, this row is for my y-intercept. The slope is the bottom row, because that's the one where what we're dealing with is everybody with me? Okay, so as I go to do my interval, and I need to do b, oh boy, b plus or minus t star times the standard error of b. What is my estimate for b? negative 0.00344. I'm going to leave it there. Okay? Plus or minus? We got to find T star. Well, let's draw a picture of T star. Well, we say, well, what do we know about the graphs of T's? They have a mean of 0, and they have degrees of freedom. What would my degrees of freedom be? Good guess, but it's actually your sample size minus 2. Whenever it's 1 for each variable. Think of it that way. Okay? So in this case, my degrees of freedom would be 14. I got that by taking n minus 2. Okay? And what's our level of confidence? 90. So this middle area is going to be 90. What does that make each tail? 0.05. Now, you guys, over and over and over again on the Unit 7 test, I was helping kids with corrections, and they calculated the wrong T star because they did the inverse T of 90, which inverse T only deals with left side. So you need to give it, if I want to find this T star, I want to be to where the left-hand area is 0.05. And I think it's 1.77 or 1.76. Is that right?
Yeah.
All right. Now, what about the standard error of B? It is 0.0007414. Any questions on where these values are coming from?
Wait, I'm sorry. Why did you write 1.75 instead?
Because it's the first Monday after a vacation. How's that? You guys, can we get to an interval from here?
Yeah.
We'll worry about that tomorrow. So like I said, I'm doing this for the recording. Guys, we're going to go ahead and we have our interval all made up. So let's go ahead and put that in our calculators. Okay? And what are we getting for the minus when we throw this in the calculator? Negative 0.00474. Perfect. Okay. And for the upper? So when we add those two, what are we getting?
Negative 0.00213.
All right. Now, if you have the raw data, you can just put this into your calculator. We're just typing this into the calculator.
What? T interval?
No. You're doing negative, like you're typing this.
Oh.
We're calculating it by hand. In order to use the one on the test, there is a linear regression T interval at the bottom, but you have to have the raw data. So if all we have are the summary statistics, we do it by hand. So you're literally just typing the two sets in. Okay? Now, there's something I want us to be very, very clear about, and I know that this is something that is commonly a problem for students, okay? You guys, what would the slope of a line between two variables that aren't related at all, what would it look like? What would that line look like? Two variables that aren't related at all.
Would not be
Well, even if they weren't linear, they could still be related. So, tell me, how could I draw a scatter plot of two variables that are not related at all? What would that scatter plot look like?
It's just like red.
Say that again?
You said no. I mean, wouldn't it just be random dots like everywhere?
Alright, you guys, if I had to draw in on this scatter plot a line of best fit, what would that line look like?
It'd just be a horizontal line.
It would be a horizontal line. Is everybody with me? Horizontal lines have no relationship. And what's the slope of that line?
0.
0. We're going to come back to that a lot today. So, as we're looking through this in a horizontal line, the slope of 0, we might look at this initially. We might look at this value for the slope from our sample and say that is pretty darn close to 0. Do you guys get what I'm saying here so far? Okay. Does our interval suggest that the slope could be 0? Not at all. Because
It's all negative.
the whole interval is negative. 0 is not in that interval. So is there a relationship between these two variables?
Yes.
Yes. Now, is it a strong relationship? Can we use the slope? I'll rephrase that question. Should we use the slope to decide if the relationship is a strong relationship? Like that slope, while it's negative, is still kind of close to 0, right? Is that enough to make us think? So I want to talk about that slope a little bit more. Are you guys with me? That the way this was set up, it measured the fat gain in kilograms. Are we with me? We good? What if I instead said just grams? What would happen to each of these numbers? What would happen to the 1, the 2, the 3, the 4? How many grams are in a kilogram? 1,000. So now this would be 1,000, this would be 2,000, this would be 3,000, this would be 4,000. So what would that do to my slope? Would it change the slope?
Yes.
Yeah, it would. Because here's the deal. My change in y got multiplied by 1,000, but my change in x did not. Is everybody with me? Okay. So all of a sudden, this exact same interval would be negative 4.74 and negative 2.13. Now that interval is nowhere close to 0. And it's the exact same data set with different... just with a different scale. Okay? So that relationship between the two things didn't change just because we changed the scale. Are we still comfortable with this? What do we typically use to measure the strength of a linear relationship?
This is r squared.
Well, it's r.
R.
And you guys, could we find r from the information we've been given? What do I do? Let's see. I know r squared is 0.606, yeah? So if I wanted to find r to measure the strength of the relationship, I could take the square root of 0.606. And I don't know what that is, but I'm sure one of you guys does. I could guess it, but it would be not very good. Maybe 0.78, 0.79. Maybe 0.77.
0.778.
0.778. Is that what r is?
Yeah.
Trick question. It is not what R is. R is negative 0.778. How do I know it's negative?
Because there's a negative correlation.
The correlation is negative. If the slope is negative, then R is negative. And R will not change if I'm measuring grams. R is what we use to measure strength. Okay, we can't use the slope and it being close to 0 to measure strength, because slope is so much dependent on the scale of the question. Are we doing okay? All right. Does anybody want to guess what the interpretation of this confidence interval is going to be? How should I start it? We are 90% confident that the interval from negative 0.00474 captures the true slope, or the slope of the true line relating an EA change and fat gain. Are we doing okay? Now, if we really wanted to, if we go to stat and we arrow over to test, at the very bottom, you have a linear regression t-interval. You can't pick, but as I hit enter there, do you guys see that it's not asking me for any summary statistics? It's asking you for the raw data. Okay? What you would need to do is type these two tables up top into your L1 and L2, which, by the way, this is one long table, not two short tables. Right? So you would all of these into your L1 and then all of these into your L2. You guys get what I'm saying here. And I think it's better off doing it by hand with the summary statistics than to type all of those in. Does that make sense? Not to mention, you should probably know what to do if you weren't given the raw data, because, say, on the quiz, I'm not giving you the raw data. Because I don't want you spending time typing them in. I don't want to decide, did you put a decimal place in a wrong place or switch two numbers around accidentally.
Do you think we would get the raw data on the AP exam?
Not likely. What's going to happen on the AP exam with this topic is going to be a multiple choice question where you have to make a conclusion, and they'll give you like this table or something, or it'll be a conditions question. I can't see them giving you more than one multiple choice question about this topic. The odds of it showing up in a free response question, I've only seen it show up in one free response question, and all it was a standard linear regression question. And then part D said, is there convincing evidence? Which we're about to learn, where we find our t-scores and p-values, though certainly I think you guys could stare at this table and figure out p-scores or t-scores and p-values pretty quickly.
Oh, yeah.
Do you guys get what I'm saying now?
Yeah.
Okay. So in my head, it makes more sense for you guys to do the actual formula than do the stuff in the calculator, because I can't even guarantee. You need to be familiar using the formula. Is everybody comfortable? We ready to do a test real quick?
So sorry. Well, we have is the formula on our formula sheet? No.
What is on your formula sheet is, all right.